way, the physical structure of parasites resembles that of our own.
They have a complexity of structure and function that is hard to believe. Most of the parasites I work with have structures that are just like man. They have intestinal systems, they have their own kidneys, they have a complex nervous system.
Organisms such as bacteria and viruses also require nourishment and protection from a host for survival. The difference between these microbiological organisms and the classic parasite comes down to size.
Usually when we talk about parasites, we talk about either single-celled or larger organisms. We don't talk about smaller organisms such as viruses for sure, and usually bacteria. Bacteria are usually considered kind of as a separate grouping.
Scientists group parasites into 3 different categories.
Parasitologists will think about the organisms that they study, the parasites, along 3 major lines. These would include simple single-celled organisms, classically protozoan organisms, such as organisms that cause African sleeping sickness, Plasmodium, which causes malaria, Cryptosporidium, which causes cryptosporidiosis, which even despite their tiny size can still be associated with devastating disease.
Then there are larger multicellular organisms, generally referred to as worms.
3 different kinds of worms that we classify as parasites. We have roundworms, like Ascaris and pinworm. We have flatworms that are non-segmented. Those are the schistosomes. And then finally we have the ones that everybody is familiar with, the tapeworms, that are segmented flatworms.
And then there is a series of organisms that are generally referred to as ectoparasites. Ecto meaning on, so they don't live in the host, they live on the host.
Mosquitoes take our blood for egg production. Black flies suck our blood for egg production. We would consider fleas the same thing. All of those are ectoparasites, but they're temporary parasites for the most part. We know of a few that are not so temporary, though. We can talk about head lice, we can talk about pubic lice, and we can talk about body lice. And in those cases, they live on us, and they depend on us, and we are their home.
In order for a parasitic infection to take place, the parasites must first gain entry into a suitable host.
Since parasites are perceived as being everywhere, some of us think we can even catch them by breathing in the air. This is not true. There are really only 3 different ways we can catch parasites, the ones that we're discussing. And that is, we can eat them, we can drink water in which they have stages, so that we can catch them this way. There's even one we can catch by sexual intercourse. But the vast majority of the ones that we're really afraid of, the ones that cause the most suffering throughout the world, are the ones that are transmitted by arthropod vectors.
A vector is generally thought of as an organism that transmits a parasite from one place to another, from one stage of its life cycle to another.
But we don't even have to go to the parasites. The parasites will come to us. They have their own transportation system, so to speak.
Mosquito vectors are responsible for transmitting some of the most dangerous diseases on Earth. One example is lymphatic filariasis.
Lymphatic filariasis, which is also known by its common name elephantiasis, is a vector-borne parasitic disease caused by a roundworm, a nematode. It's a very widespread disease throughout the tropics, thought to involve somewhere in the order of 120 million people or so around the world.
For most people, a filariasis infection brings about only mild side effects. But when the disease infests the lymphatic system, severe pain and intense suffering result.
The lymphatic channels can be in various parts of the body. Classically, it's in the lower extremities. So the adult worms are in the lymphatic channels of the legs. And it impedes the return flow of lymph fluid, causing buildup of lymph fluid and the subsequent swelling, and then the fibrotic reaction that the body has over years, and then the infections of the skin that are caused by the compromised lymphatic flow that result in the fairly grotesque classic elephantiasis of the lower extremities. The common underlying result is debility, severe inability to perform one's daily routine.
The disease is very hard to diagnose in its early stages.
One of the very frustrating things about this parasitic infection is that in its early stages, it's clinically very silent. So you can get fairly young children that actually become infected with this parasite, and unless you look in their blood to see the embryonic forms of the parasite, you wouldn't know that they were infected. And then very gradually over years, as they enter puberty and adult life, they will begin to manifest slight swellings of one leg, or a hydrocele, or a swelling of the scrotum, that just gradually over time gets bigger and bigger, inexorably. Once they reach that stage, there's not much that can be done medically to try and cure them of that.